Hi there, in this video you're going to learn about similar figures. Your objectives for today are to find missing measures of similar figures and to use scale factors to solve problems. Before we begin, I need you to understand what these two symbols mean. This symbol, squiggly line, means that it's similar. This symbol means congruency. So you use this to talk about when two shapes are similar. You use this to talk about when two shapes are congruent. And I'll get into what each of those mean in the next slides. Similar figures have the same shape, but not necessarily the same size. So their corresponding angles are congruent. So in other words, you have the same measure. That's what congruent means. They mean you have the same measurement. Also, with similar figures, the corresponding sides are proportional and opposite the corresponding angles. All right, so let's look at this for 1 second. We have two shapes here that are similar to each other. Angle A, here it says triangle ABC is similar to triangle XYZ, okay? So ABC is similar to XYZ. The angles are congruent to each other, right? Corresponding angles are congruent. So angle A is congruent to angle X. Angle B is congruent to angle Y, and angle C is congruent to angle Z. If you notice, this has one tick mark, this has one. This has two, this has two. This has three, this has three. That's how you show what angles are what angles are congruent to each other. So like this is congruent to this because there's only one line. This is congruent to this because it has two lines. All right, so we all understand that the corresponding angles are congruent. So even though these two shapes are different sizes, the angles are still congruent. Now, let's look at the sides now. Let's talk about the sides. Corresponding sides are proportional and opposite corresponding angles. So let's look at this. AB is proportional to XY, and BC is proportional to YZ, and AC is proportional to XZ. So all these sides are proportional to one another. They correspond to one another. Okay, so you can make a proportion with like AB over XY is equal to BC over YZ, and they'll all be proportional. The ratios for the corresponding sides, if you were to input numbers here, they would all be the same ratio. They would all be equivalent to each other. All right, so figure ABCD is similar to figure EFGH. And symbols ABCD is similar, you see this? EFGH. Okay? So sometimes in your examples, you're just going to be given this. ABCD is similar to EFGH, and you need to know what that means. Okay, so similar figures have corresponding parts. These are angles and sides in the same position. So AB, what position is the same in this figure as AB? Well, it goes with EF, right? So this side corresponds to this side. BC would correspond to FG, right? BC, FG. DC corresponds to HG, or CD corresponds to GH. It doesn't matter which way you say. Your line segments. They're both the same. And DA, HE, right? So that's with our corresponding sides. Our corresponding angles, again, what are the angles that are in the same positions? What's in the same position as angle A? Okay, angle E. What's in the same position as angle B? Okay, angle F. All right? So that's how you find your corresponding angles and your corresponding sides. The figures are similar. Find each missing measure. So here you're given two similar figures, okay? If you don't even need this preface here that the figures are similar. You should be able to see these two figures and be able to tell that they're similar because of the tick marks, right? All right, so Since triangle ABC is similar to triangle DEF, the corresponding angles are congruent and the corresponding sides are proportional. Right, we just learned that. So since triangle ABC is similar to DEF, the corresponding angles are congruent and corresponding sides are proportional. Let's go over this for a second when we start our proportions. So we have BC over EF. Okay, so when we go to start our proportions, we're trying to figure out what this is, this X centimeters, okay? So we're going to start off by figuring this out using our proportion. So what you do is you're going to find a proportion. So you're going to find the ratio from this little triangle to the big triangle using the corresponding sides. So let's start off with this BC. BC is 6 centimeters, right? And EF is X centimeters. So the ratio from small to big is 6 to X. 6 over X is equal to, let's go again from small to big, AC over DF, right? Small to big. So now you're going to replace BC with 6, EF with X, and AC with 4, and DF with 12, right? So all you're doing is just replacing. BC is 6. You don't know what this one is, so you leave it as X. AC is 4, and that's corresponds to DF, right? Which is 12. And now you can go ahead and solve this, right? So 6 times 12 is equal to X times 4. 72 would equal 4X. Divide both sides by 4, and you get 18 to be X. So this length of EF is actually 18 centimeters. So again, all I did, I made a proportion from little to big is equal to another proportion, 4 to 12, right? All I did, I just made these two ratios equivalent to each other, and then I solved for X. Here's another example. We have figure RSTU is similar to figure WXYZ. Corresponding sides are proportional. Okay? So it tells you the corresponding sides are proportional. So let's do this. Let's do from this to this. Okay? So we have RX and WX, right? If you notice, this is actually a mirror image that's flipped, right? So this is flipped over to this. Okay, so that's why this RS corresponds to WX, okay? All right, so RS corresponds to WX, right? And that's equal to, well, we're trying to figure out D, and we're given 28 here and 4 here. So whatever you start off with, I'm starting off with big, right? Big to small. So now here I'm going to do big to small. So here I'm going to go 28 to 4. This RU over WZ. Okay? And now you're just going to replace the letters. So from big, 49 to small, D, 49 over D is equal to big, 28 to small, 4. Okay? Now you can just solve the proportion as you normally would. So again, the top is the big, the bottom is to small. If you want to go from small to big, that's fine. You can have small to big, but you just need to make sure that you have the right correspondence here. So now we can do our cross products. 49 times 4 is equal to D times 28. 196 is equal to 28D. Divide both sides by 28, you get 7 to be D. So the length of the line WX is 7 feet. So WX is actually 7 feet. All right, scale factor. Recall that the scale factor is a ratio of a length on a scale drawing to the corresponding length on the real object. It is also a ratio of corresponding sides in similar figures. So let's talk about how we can use scale factor. A rectangular blue tile has a length of 4.25 inches and a width of 6.75 inches. A similar red tile has a length of 12.75 inches. What is the width of the red tile? Let's start off doing the ratio of the lengths is equal to the ratio of the widths. So our lengths are 4.25 to 12.75, and our widths are 6.75 over x. Now here we can just solve, cross multiply, and solve, and you get your answer to be 20.25. All right, so I hope you learned about similar figures. Thank you for watching.